Hello, good morning all. I'm Suhasini. Welcome back to my channel Learn with Suhasini Shinde. In the very last class, we learned about gold leaf electroscope, and to that previously we learned about electrification and methods of electrification. Right? In today's class, we'll be learning about basic or the fundamental properties of electric charges. Right? Now this particular fundamental charges or the basic properties of the fundamental charges, we have three main fundamental properties of electric charges, right? The very first one is additive nature of the charge. The second one is conservation of the charge, and third is quantization of the charge. Now this topic is very important in exam point of view. May it be your theory or it can be your NEET or JEE, right? This question is asked very separately. Independently they can ask you to explain what is additive nature of the charge, or independently conservation of the charge or quantization of the charge, or they can ask you togetherly clubbing all or explain all the basic and the fundamental properties of the charges. Then you need to explain all additive, conservation and the quantization of the charge. If they are asking all the three fundamental properties, then it could be for say for example 2 or 3 marks, right? And if they ask independently, then it will be asked for 1 mark, right? Now this is a very important concept. You please do learn it properly, right? Let us start one by one. Let us start with the very first one, that is additive nature of the charges, right? What this additive nature of the charge explains is, it says the total amount of the charges or the net charge of any system will be equal to the algebraic sum of the charges that are present into that particular system. Say for example, if you have a system, right, and you have so many charges into it, say for example Q1, Q2, right? What does this Q represent? It represents charge, right? You have Q3, you have Q4, right? You have so many charges up to Qn, right? What the additive nature of the charges says here, the total or the net charge of the system will be equal to algebraic sum of Q1, Q2, Q3, Q4 and all other charges that are present inside the system, right? How does this represent? The net charge will be equal to Q1 plus Q2 plus Q3 plus Q4 plus dash dash up to Qn. Whatever number of the charges the system carries, right, the algebraic sum of all the charges will be equal to the net charge of this particular system, right? Is that clear up to this point? Now next, say for example, you have a system A, right? You have a system A which is initially neutral. What does neutral system means or balanced system means? By this time you have to understand what the system is, right? Whenever electrons are equal to proton, then that particular system is called as neutral system, right? Say for example, you have added 2 electrons and you also add 3 electrons to this particular system, right? What happens? What is the total net charge of this particular system now? The total net charge of this system will be 2 electron plus 3 electron is equal to 5 electron, right? Is this what additive nature of the charge explain, right? The additive nature of the charge says that any amount of the charges that are present here, individual addition of all the charges represent the net charge of that particular system. Now let us consider, again you have a system where you add 2 electrons initially, right? Again you add 3 electrons. Later you remove 2 electrons, right? Now what is the net charge on this particular system? It is, the net charge on this system will be plus 2 electrons, plus 3 electrons and minus 2 electrons. This get cancelled. The net charge of this particular system will be 3 electrons, right? What all this process implies? This all process implies that the total net charge of any system will be equal to the algebraic sum of the individual electrons or individual charges that are present inside the system, right? And this implies that all the charges are additive in nature, and hence it is called as additive nature of the charges. This is the very fundamental and the basic property of any electric charge. Is this clear, right? This particular question can be asked, right, to explain you for 1 mark. Say for example, explain how the additive nature of the charge takes place, or explain how the nature of the charge are additive, right? This can be asked as 1 mark question. Is this clear, right? And the very next property of the charge is conservation of the charge, right? What does this conservation of the charge says? Charges neither be created nor it is destroyed. The charges can only transfer from one place to another place only in an isolated system, right? Now what do you mean by isolated system? Say for example, you have a system, right? You have two subsystems, that is subsystem A and subsystem B here, right? Now this is called isolated system. You have another system, say for example C. Isolated system is a system where it can interact only with the systems that are present inside the this particular area, right? Any system that is present outside will not be able to interact with either of them, right? And hence the transfer of the charges takes place only between these two that is systems, right? The C, neither can it interact with B nor it interact with A, as because it is not a part of the isolated system. Is this clear? Right? Now this is an isolated system where it consists of two systems internally. One is outside. This will neither react to B, neither react to A. This kind of the system is called as isolated system. Is this clear? Next, when we have an isolated system, say for example A and B, right? Now A consists of 2 microcoulomb of charge into it, and B consists of 3 microcoulomb of charge, right? Now what is the total net charge on this particular system? Net charge of this isolated system will be, due to A we have 2 microcoulomb, right? And due to B you have 3 microcoulomb, right? The net charge of this isolated system will be equal to 5 microcoulomb, say for example, right? Now again this is a isolated one. A is transferring 1 coulomb of charge to B, right? When A transfer 1 coulomb of charge from point A to point B, how much is the charge that is remained in A? It remained 1 coulomb, that is 1 microcoulomb of the charge is remained here, and 1 will be added here, so 4 microcoulomb of charge is present here, right? After the transfer of 1 microcoulomb of the charge from system A to system B. Now what is the net charge of this particular isolated system? Now again, because of A it has 1 microcoulomb, and because of B it has 4 microcoulomb. Now the total is 5 microcoulomb, right? The net charge remains same with any transfer of the charges that takes place internally in the isolated system, right? At this particular point, this process conveys you that, right, charges neither be created, charges nor be destroyed. It can be transferred from one system to another system within an isolated body, right? In the very previous one, when A had 2 and B had 3, the net charge was 5 microcoulomb, right? In the very next point, when 1 coulomb of charge was given to the system B, right? Even then the net charge remained the same, that is 5 microcoulomb. In both of the cases, we had 5 microcoulomb of the charge in the isolated system overall. And hence, this process says you that charges are conserved in nature, right? It cannot be created nor be destroyed, but it can be transferred from one system to the other system internally in the isolated system. Now here the third fundamental property of electric charge is quantization of the charge. What does this quantization of the charge says? Quantization of the charge is the charge can take only the integral part or the discrete value of the charges. Say for example, Q is equal to N into E. Now you know that what Q is? Q is charge, right? Now this electron could be the integral or it can be only integers, right? This N can be 0, plus or minus 1, plus or minus 2, dash dash up to plus or minus N, right? Now this integer or this electron can take only the discrete value of integer. Now how is this explained? Say for example, you have a system, right? In this system, You can add electrons or you can remove electrons, right? If at all you are adding the electrons, it should be 2 electrons is added, 10 electrons are added, 7 electrons are added, right? And if at all you have another system where you remove the electrons, 10 electrons are removed, 5 electrons are removed, 2 electrons are removed, right? There are two possibilities. Either you add the electron, either you remove the electron, right? But it cannot be you are adding 2.5 electron to the system or removing 7.5 electron to the system, right? The electron that is added to the system should be integer. Either it should be 2, 7, 5, 6, 10, whether you add or whether you remove, right? If at all added, then that indicates addition of the electron, that is plus 2, plus 3, plus 7. If at all you are removing the electron, then it is indication as minus, that is minus 5, minus 7, minus 2, right? And so on, right? You cannot add or remove the electron in terms of fractional or the decimal values. You cannot add 2.5 electron, you cannot remove 10.6 electron, right? The electron that is added to any of the system should be an integer, right? If at all you are adding no electron, then n value will be equal to 0, right? If at all you are adding 1 electron, then n value will be plus 1 e, right? If at all you are removing 2 electrons from the system, it should be minus 2 e, right? If no electrons are added or no electrons are removed, then n value should be 0, 0 e, right? What the ultimate process or what the step says that the quantization of the charge explains is the charges, whether it is added or whether it is removed, should only be the integer. It cannot take any fractional or the decimal value, and hence this process is called as quantization of the charge. Right? After the explanation of the basic and the fundamental properties of the charge, let us move the general properties of the charges, right? Now you do not confuse, right? If they ask you to write the basic and the fundamental properties of the charges, then it should be additive, conservation and quantization. If they ask you in general what are the properties of the charges, then these properties of the charges has to be explained, right? Now let us see. The very first property of the charge is like charges repel and unlike charges attract each other. You always know that whenever you have two like charges, say positive, positive or negative, negative, like charges always repel each other, right? If at all you have opposite charges, that is positive and negative and positive, they attract each other, right? This is the first property of the charge, that is like charges repel each other and unlike charges attract each other, right? The very next property is charges can be either positive, either negative, or it should be zero. The value of the charge is positively charged, either negatively charged, either it should be neutral, the neutral value will be zero, right? This is the second property. Now the third property is charged body attracts the lighter object. Whenever you have a charged body and you have so many other bodies, right, the charged body will always attract the lighter body through induction, right? You should remember this, right? This is the third property of the charges. Property is charge cannot exist without mass. Now what does this mean? Whenever there is mass, there are two possibilities, whether the mass can have the charges or it cannot have the charges. But when you have a charge, there should exist some mass, right? Without mass, charge doesn't exist, right? This is the fourth property. What is the fifth property? Charge is quantized. As this has been explained in the fundamental properties of the charge, whenever you have a charge, any addition or removal of the electron takes the discrete value of the integer. The electrons are added or removed from a system only in terms of integer, plus 2, minus 2, plus 5, minus 5. It cannot be 2.5, 6.9, any fractional value or decimal value cannot be taken, and hence that particular process is called as charge is quantized. That is quantization of the process, right? The next property is electric charge is not dependent on the speed. Whatever the speed of the object or whatever the speed of the body is, right, it cannot depend, or the speed is not dependent, or the charge are not dependent on the speed, right? Whatever the body object is, whatever the body speed is, right, the charges are not at all dependent on the speed or the acceleration of that particular body, right? Next one is charges additive. This is also being seen in the very fundamental properties. Any charges, the overall net charge of any isolated system or any system will be equal to the algebraic sum of all the charges that are present inside the system, right? That is called as charge is additive in nature, right? The very next is charge always reside on a surface. What does this mean, charge always reside on a surface? Say for example, you have any surface, you have sphere, you have cylindrical surface, any amount of the or any shape of the surface, right? Charges always resides on its surface. The charges cannot be present internally, right? The charge are always present over their surfaces, right? This is the property of the electric charge. Charges cannot be present here inside it, right? Charges are always present over their surfaces, right? That is what this says. Charges always reside on the surfaces, right? Next is accelerated charges radiate electromagnetic wave. Whenever a charge accelerates, right? Whenever a charge, say for example, this is a charge. Whenever this charge is moving, it radiates electromagnetic waves, right? These are electromagnetic waves. When charge start accelerating or moving, right, it always radiates electromagnetic wave. This is the characteristics or property of the charge, right? Next, electric charge is scalar quantity. You understand what scalar and vector quantities are? Any quantity which has both magnitude and direction are called as vector quantity, right? And any quantity which has only magnitude but no direction, then it is called as scalar quantity, right? Electric charge is a scalar quantity. It has magnitude. When you say electric charge, it could be 2 coulomb, 3 coulomb, nano coulomb, micro coulomb, any amount of the coulomb which has magnitude. But you cannot say electric charge in direction, right? Say for example, force, you can say force. What is force? You say force is 2 Newton, 3 Newton in some particular direction. When we say force, the force is always in some direction. Then what does this mean, force? The quantity force is vector quantity which has both magnitude and direction, right? But the scalar quantity are the quantities which have only magnitude, 2 coulomb, 3 coulomb, but no direction, right? And hence electric charge is scalar quantity, and the SI unit of this particular scalar quantity is coulomb, right? That is electric charge SI quantity is coulomb. And next is, last is, charge is conserved in nature. Now this even is being explained in the fundamental properties of the charges, right? Charges are conserved in nature. What does this mean? Charges neither be created nor be destroyed, and hence it can be only transferred from one point to the another into an isolated system, right? These are all the properties of the charges. These properties includes all the basic and the fundamental properties of the charges, right? If they ask you only the fundamental properties, then you should explain the conservation, additive, and quantization, right? If they ask you the properties of the charges, then these all properties has to be explained, right? And this particular question is very important from exam point of view. This can be asked for 2 marks or 3 marks, right? Is this clear, everyone? This is what for the today's class. In the very next class, we'll deal with the Coulomb's law, right? And the material for this particular chapter, that is electric charges and the fields, will be given in the description box. You please do visit my website and you can download the notes and study, right? And please do watch my videos and share with all your friends and family, right? And thank you so much.